All right, so let's work through some examples of exponentials, but specifically dealing with finances, all right? So here are the two equations, the primary equations we will work with. So let me define the parts of these. So A, and this is for both of them, this would be the future value. You put some money in the bank, you come back 10 years later, how much money do you have? That's the future value. And let's see here, we have the P, this would be the present value. That's what we start with. And then you can see we have T. T would be the number of years. And it's the same T right down here, number of years. R, this R right here, this is the interest rate. Interest rate. And this will be always a percentage per year, okay? So when they give you the interest rate, it's going to be always per year. And again, same R is up here. And notice we have ends here, but we don't have the ends down here, right? We've talked about all these. Actually, let me tell you real quick here. E is a constant. It's kind of like pi. E is equal to 2.718, and it goes on. That's certainly enough decimals for us. So E is actually just a value. It's that number right there. And then the last part is, notice we have the ends here. And the difference between these equations, let me explain the difference, okay? When we have the E without the N, this is continuous. Okay, this equation is for continuous. And I'll tell you in the problem, interest is compounded continuously. Up here, this one is compounded so this one they might tell you is compounded monthly. Well, if it's monthly, N would be equal to 12. Okay, that N right there. If it's compounded quarterly, like 4 times a year, N would be equal to 4. So again, this would be monthly. This would be quarterly. You can imagine if it were compounded, if your interest is compounded yearly, well, N would be equal to 1. If it's compounded weekly, N would be equal to 52. You could even do compounded daily, which is, you get a big number there, 365, when you put that in there for your exponent. There we go, continuous. So this here will be compounded certain number of times per year. And, oh yeah, N equals 1 if it's yearly. The more times you compound, the more often you compound, the more interest you make. So continuously will be the most, and it kind of works their way down. I didn't put these in order. So if it's only compounded once a year, that's going to be the least amount of interest. All right, so now with that background, let me erase this part here and let's work a couple of example problems, okay? So in this problem we're going to do, the first one, we're going to find the future value. In other words, we're going to find A. The next question is how do you know which equation to use? And that comes right here. Compounded monthly, right? And so right here, R is equal to 0.03. You know, move the decimal over. Monthly means that N will be equal to 12. T will be equal to the number of years right there. And this is P, our present value. We start with $5,000. So we're going to take this equation here. And again, we're not using this one because this would be for continuous. So A equals P. Our P is $5,000. Times 1 plus R is 0.03 divided by 12. raised to the power of n, which is again 12, times t, which is the number of years, which is 8. So there we go. So let's work this through. Hopefully while I'm writing this out, you can help me by plugging it into your own calculator and making sure you're getting the same values. So we have here $5,000 times, so 0.03 divided by 12. If you add that to the 1, we're going to get 1.025. Raised to the power of, that will be 96. And now thinking about PEMDAS, we have a choice multiplication or exponent, so of course we'll do exponent. So 1.025 raised to the power of 96 then would be, so 5,000 times, this is going to be 1.270, and this may seem extreme, 868. I'm carrying roughly the number of decimal places in here as I want to have in my answer, and you'll see in a little bit. So now multiplying those out, so the future value is equal to $6,354.34. If I didn't carry as many numbers out here, I really couldn't justify telling you how many cents it is. So you can see here we have 6 places, so it looks like we carried just 1 extra decimal in there. All right. So there's one example. I'd like to erase the board and do another example for you. All right, so here's our next problem. We're going to find the future value again of 5,000, but this time compounded continuously at the same interest rate for the same length of time. So we're going to drop down to this equation here. So our future value is equal to P, the present value, $5,000, times, oops, I'm heading back to the other equation already. Let me erase that. Times E, and again, remember E is just actually that number, but we'll write it out as E, raised to the power of R. So here's our rate. This is going to be 0.03. So I'll put in 0.03 times T, which is our number of years. I'll put in 8, just like that. So I have $5,000 times E raised to the power of 0.24. Now take your calculator. Some of you might have it as like E raised to the caret, something like that. Depends on your calculator. And you'd want to put some parentheses in around that 0.24, depending on how you choose to put that in. So now we have $5,000 times, and this becomes 1.27, 1249. And then multiplying those out, we find that the future value is $6,356.25. And again, this is a little bit more than we calculated before because now we're compounding continuously instead of compounding monthly. Okay, so now I'd like to flip things around. We'll do another example, but this time let's try to find some of the other parts of these equations. Okay, here's our next example. This time we want to find the present value. If our goal is to have $40,000 in the future, 20 years in the future, in fact, assuming we can find 4% interest and it's compounded weekly. Okay, so you can see we've got the word compounded weekly, so right away it's going to push us into this equation here. So let me just rewrite that. So I have A equals present value 1 plus R over N times N raised to the power of T in T. So now let's try to fill this in. So in this case, our future value is the $40,000. The present value, that's what we're going to find this time. 1 plus our interest rate. And again, that's going to become 0.04. Just move that decimal over. So 0.04 divided by N, in this case, 52 weeks. So we have 52 weeks raised to the power of 52 times 20 years. Okay, so start plugging things in the calculator here. And again, I would like you to try to just be plugging numbers in your calculator as we work through this. I think it'll help you out. So here we have P times 0.04 divided by 52, and adding that to 1 gives us a 1.000769 raised to the power of 1040. Okay, so again, I'm going to do my exponents next. So 40,000 P, and that's going to give me then 2.2249. So now to get rid of that, of course, I need to divide by 2.2249 on both sides. 2.2249 like that. And that'll leave me then P is equal to $17,978.69. So this is the amount we need to stick in the bank. We're going to leave it there for 20 years at this interest rate, compounded weekly, and we'll end up with $40,000 when we're all done. All right, so I have one more example like this for you. Let me pause and clean the board.